Hi there, my Chem 100 lab students. I hope you're having a good week. I wanted to give you a heads up on some things for next week and show you that I posted something on our Canvas site that might be of help, may or may not. If you look at the end of experiment 4, so remember we have the first 4 experiments. The material on these can potentially show up on your lecture exam. I'm not giving you an exam. So I recommend that you study any of the lecture notes and look at your quizzes to make sure you could repeat some of that if it shows up on your lecture exam. And I posted a practice exam. You should have practice exams in your lecture already. But this is something that I wrote separately for my class this year in the spring. That might be of use, right? I'm not writing the exam for you in lecture, so this overlaps all the topics and it should help you study a bit. So feel free to look at that. I didn't post the answers yet because I really want to emphasize that you need to try it first and get stuck and figure out where you're stuck. That's the best way to learn. Often when I give you the answers right away, it's too easy to just sort of look at them and say, oh yeah, I understood that. And then you get to the test and realize the blank you might have had. So consider this as a supplement and try to do it on your own and then look forward to a key that I'll post sometime in the weekend. Okay, so 1 to 4, please study for your exam. Lab 5, this is material for your second exam in lecture. This is our lab for this upcoming week. Now for this lab, we're not actually going to meet live. You're going to be going through all of these examples. This is a dry lab, which means we're not actually doing any experimentation. You're spending the entirety of the lab going over all of these metals versus non-metals so that you can figure out how to name a compound. And that's what nomenclature is. So when I tell you, oh, we have some carbon dioxide, why do I call it carbon dioxide? How many atoms are there? Why don't I call it carbon dioxygen or monocarbon oxygen, right? So all the rules that are kind of hidden in a chemical name, that's what this is all about. So it looks kind of long, but it's meant to be a lab period. So I recommend you do this during our normal Tuesday lab period. And it should take a few hours. What you're going to do is click through all of these. So for example, there's a video with the review of metal versus nonmetal. Then there's a practice quiz on metals versus nonmetals. And you can take it as many times as you want. Right? So you will be tested on which element happens to be a metal or nonmetal. So this is the idea of nonmetals on this side, metals over here. Remember that you have transition metals in the middle. These two are the main group metals. Right? The first group is your alkali, and these are your alkaline earths in the second group. So recognizing metal versus nonmetal. That's important. That's the first step in naming. Then you're going to decide if it's an ion or a compound. There are videos that lead you all through this. And remember, to be an ion, it's going to have a charge, right? It's going to have a negative or a positive near that compound. And there's practice. So everything has a tutorial and some practice and a graded quiz that you can take multiple times. Then we have classification of the chemicals. Is it an element? Is it a molecule? Is it a compound? And we did some of this in lab already. So a lot of this kind of will solidify metal versus nonmetal, element, compound, atomic, diatomic, all of that. Right? And then the classification between ionic and molecular. So ionic is usually made from a metal, nonmetal. And if you have a metal and a nonmetal together, that's ionic. And if you have two nonmetals together, that's molecular. So if I were to put carbon, which is a nonmetal, with two oxygens, this is a covalent compound, right? I'm going to have two nonmetals. But if I take magnesium and stick it on oxygen, now I have an ionic compound because I have a metal, nonmetal. And this is all described in excruciating detail for you to go through these videos. Then you get to naming. So how to name covalent, so when you have two nonmetals together. Why did I call it carbon monoxide or carbon dioxide? Those are the naming rules. Right? And then you're going to practice ion naming. So you're going to do compounds that are ionic or covalent. Then you're going to actually do ions. This gives you a list of ions that you need to memorize and some practice with those namings. Transition metals and how to name them. Those are the particular ones in yellow here. Transition metals often require Roman numerals. So there's a little bit difference there. Polyatomic ions, these are ions that have more than one nonmetal stuck together. And at the very end, there's preparation for next week. When you click on these ion cutouts, you're going to see something like this. And the whole point of this lab is these set you up for next week. So you don't need to upload anything. You're just going through all of those experiments. What you're going to do is you're going to notice that all of the cations, the positively charged ions, will have forward-facing, in this case it's not really the notches. These are the teeth. So all of the cations have the teeth. And they have the number of teeth matches the charge of the ion. So aluminum has 3 teeth. Sodium has 1 tooth. Potassium has 1 tooth. And you can predict this based on position. Everything in the first group has 1 tooth. These have 2 teeth. These can vary. That's the important part of transition metals. I can have iron with 2 teeth. I could have iron with 3 teeth. And then you'll notice that the anions, the negative charges, they have the notches that match. So because sulfur is a -2, there's 2 notches. And this helps you understand how to write an ionic compound. So you'll simply be cutting these out. So ideally you can print this. There's 2 of them. There's a blank one that just has 3 teeth and 2 notches, for example. It has a variation for you to write your own elements in them. And there's one where they're actually filled in color. So you can either print these out. So I've printed mine out and I'll be cutting them out along the lines. And you'll notice that if you put calcium and sulfur together, they need to fit. So 2 teeth, 2 notches. That compound is calcium sulfide. And there's 1 calcium and 1 sulfur. And like I said, that's the point of the following lab. So you'll simply be cutting those out to prepare. And if you don't have a printer, you can get a piece of paper and draw them on your own and cut them out, however you would like to do it. And there's 3 pages of the same thing, in case you want to have multiple copies. Alright, and finally at the very end here, there's a naming quiz. This quiz, we ask that you only make 1 attempt, because this is kind of the culminating quiz. All the quizzes here, you have mini quizzes with multiple attempts. they prepare you for this final quiz. So you'll essentially get a question about, 1 or 2 questions about polyatomics, 1 or 2 questions about transition metals, etc. All right. So we won't be logging in live to Zoom for our lecture next week, for our lab, apologies. And I will send a follow-up with some more information. All right, but in the meantime, good luck on your test. Have a look at the practice exam, and if you're behind on anything from labs 1 through 4, let me know if you need any help, and try to get those in before your exam on Tuesday in lecture. Take care. Over and out. See you soon.